Okay, continuing on. Now we're looking at, again, it's up to you. I'm going to do this two ways. I'm going to say, assume we had negative x squared over 16 plus y squared over 9 equal 1. So this is not needed, but I strongly suggest that you do that, especially with the asymptotes and the shift. It becomes very annoying. So this extra graph is not needed, but I'm going to do it anyways. So I know that the center is at 0, 0. I'm talking about the blue equation. I am going to move 4 to the right, 3 up, so since the negative is in front of the x, I know the vertices are at 0, 3, and 0, negative 3. Foci, square root of 16 plus 9, that's square root of 25, that's 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that is at 0, 5, negative 5. Very good. And the asymptote y equal the rise, which is 3 units, over the run x. Now, this is how it's going to work. Since I already have the graph, I'm going to mimic the graph on the right, and look how that works. I'm going to go to my center. My center is actually negative 3, 0. Negative 1, negative 2, negative 3, 0. Oops. Negative 1, negative 2, negative 3, 0. From this point, I'm going to move 4 to the right, 4 to the left. 1, 2, 3, 4. 1, 2, 3, 4. 3 up, 3 down. 1, 2, 3, and 1, 2, 3. So here, it doesn't have to be a perfect graph. Here, I need to make it as accurate as possible so everything matches. 2 lines passing through the edges. And I do notice that I went from this point, 5 above, 2, 3, 4, 5, and 5 below, 1, 2, 3, 4, 5. Forget to graph it here. It looks like this, right? There's the graph. The labeling, well, guess what? We're going to use that trick. We're going to add a negative 3 to all of these x's. So when we go for the vertices, we're going to say 0, that's a negative 3, that's a negative 3, that's a negative 3, that's a negative 3. Since these match, you leave the y alone in this case. Whatever that is, you copy down the y. And the equation of the line is fairly simple. Whatever this is, replace y by it. And whatever this is, replace x by it. That's the equation of the asymptotes. And there it is. If I look at the next problem, same deal. Even though they're not asking for it, I am gonna go ahead and do 2 graphs. They're not asking for 2 graphs, but I'm gonna do them anyways. And the way this works, a rough sketch, doesn't have to be perfect because it's for my own reference. From the center, which is 0, 0, I'm going to move 5 to the right, 5 to the left, 1 up, 1 down. The negative is in front of the y. The graph looks something like this. The vertices are at 5, 0, negative 5, 0. The foci It's right next to it. Right next to 5. Asymptote. Y equal the rise. You rise 1 unit and you run 5 units. There. Now, the graph I'm going to get and I'll label after. Or I could label first and graph after. Doesn't matter. So, my center is actually 2, 1. I'm going to move 2 units to the right, 1 unit up. From this point, I'm going to mimic this. I'm going to move 5 to the right, 1 up. And you notice I'm not that worried about labeling, because labeling I'm going to use what I learned in transformation in algebra. We did that in chapter 2. The graph is wrapped around the x-axis. Well, it's no longer the x-axis now. It's x. It's shifted up 1 unit. Okay. Now I need to label the vertices, the foci. I noticed the foci was a bit to the right and a bit to the left. There it is. Now, this is how it's going to work. Add 2 to all the x's. Add 2 to all of those. That becomes 5 plus 2 is 7. Negative 5 plus 2 is negative 3. Add 2 to that. 2 plus radical 26. 2 minus radical 26. Got it. Add a 1 to all the y's. Well, the y's are 0. That's fairly simple. Just add 1 to all of those. The equation for the asymptote, that turns out to be the most challenging for students. The y, I'm going to replace by y minus 1 equals plus or minus 1/5, plus or minus 1/5. And the x, I'm going to replace the x by x minus 2. And there it is. A very neat trick. A bit longer, but better be safe than sorry. And I have one more, and I'm going to do that also to that one. X squared over 16 minus y squared over 25 equal a 1. Well, you don't have to do that if you don't want to. The labeling is more important than the graph, or as important, I should say. So, 4 in the set center here is 0, 0. Yeah, I'm doing double the work. The rise over the run x. There it is. I'm going to move 4 to the right, 5 up and 5 down. Negative in front of the y. The vertices are at 4, 0, negative 4, 0. 16 plus 25, that's square root of 41. So square root of 41, 36 is 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There. Now what? Well, the center is actually at negative 2, negative 3. So negative 2, negative 3. I'm going to move negative 2, negative 1, negative 2, negative 3. That's the center. And from there, I'm going to mimic this. I'm going to move 4 to the right, 4 to the left, 5 up, 5 down. Here, I want the graph to be a bit more accurate than the green, because the green is not part of the problem. I'm adding it. There's the graph. Oops. And 1, 2, 3, 4, 5, 6, 7. from this point 1, 2, 3, 4, 5, 6, 7. As far as the labeling is concerned, I'm gonna add a -2 to all of these x's. -2 plus 4 is a 2. -2 minus 4 is a -6. -2 plus radical 41 and -2 minus radical 41. Let me shift this graph just a bit to the right. There. This way I can have more space. And I am gonna add a -3 to all of these zeros. Well, that's easy. The equation for the line, I am gonna replace the y by y plus 3 plus or minus 5/4. And I am going to replace the x by x plus 2. If you want to match the back of the book, all what you have to do is solve for y and you get the same thing. And these must be labeled on the graph. Those worth as much as the graph, if not more. So the graph doesn't worth as much as those labeled. And the last thing to do is complete the square. Again, something that we must do. Let's get the x's. -x squared minus 2x plus 4y squared minus 8y. I'm going to move the 16 over. Factor a negative out of the x's. This has to be a positive 1. Factor a 4 out of the y's. Since this number is being multiplied by -1, I must multiply it by a -1 when I put it there. And since this number is being multiplied by 4, I must multiply this by 4 to keep it balanced. Otherwise, that equation would not hold. That would be a problem. So take half of the middle number, which is 1 and... oh, they both turn out to be the same. That's not what I wanted. Oh well. Yeah, that's okay. So negative x squared plus 2x plus 1 negative x plus 1 squared plus 4 into y minus 1 squared equals -16 minus 1 plus 4. -16 minus 1 is -17. -17, oh boy, the number is really messy. Let me change that slightly. Give me a sec. Okay, just to make the numbers work, I'm going to make that 1. -1. So when we move it to the other side, it becomes a +1. Those cancel out and you're left with a 4. And if you divide by 4 both sides, you end up with -x plus 1 squared over 4 plus y minus 1 squared over 1 equal a 1. Now this one I'm going to do without the 2 steps. I'm going to do it one shot. So I know the center is at -1, 1. I'm going to move 2 units in the x, 1 unit in the y. I'm going to say the center is at -1, 1. The vertices, since the negative is in front of the x, So at -1, 0, and 2, the foci are at -1, square root of 4 plus 1, that's radical 5. So 1, 2, 1, 2, 3, radical 5 is right there. A number between 2 and 3. So this is going to be at 1 plus radical 5, 1 minus radical 5. And the equations for the asymptotes, I know instead of y, it's going to be y minus 1. I know the rise is 1, the run is 2. And instead of the x, I'm going to use x plus 1. I could do that in every problem. I am very comfortable with this. If you are discomfortable with this, you could do that too. You really don't need the additional graph. Now, given information and coming up with the equation is a lot quicker and easier. So if I'm looking at the equation that satisfies the given conic, okay, you have vertices, vertex at 5, whoa, why so wide? Vertex at 5, -3. So if the vertex is at 5, -3, and focus at 5, 1. So this is a vertex, it has to look like that. So it is y equal 1 over 4 times p, x minus 5 squared minus 3. What's p? Well, it's right there. It's that distance. You are at -3, and you're going up all the way to 1. From -3 to 1, isn't that 4 units? That simple. The graph is not needed, but a quick sketch will give you a good idea. I have a vertex at 1, 2. That's a vertex. And a directrix at x equal -3, x equal -1, -2, -3. That means the parabola opens to the right. Right? So, this is, and if this is confusing you, it is confusing me really. I would switch x with y. I will say 2, 1. That's the vertex. Y equal -3. So 2, 1. That's the vertex. It is y equal 1 over 4 p into x minus 1 squared plus 2, plus 2 squared plus 1. Switch them, right? And if I go from -3 to 1 again, that's 4 units. So switch x with y, x equal 1 over 16 into y minus 2 squared plus 1. Just switch x with y, there it is. That's the equation. And what if I have an ellipse? The vertices are at -1, -2, and -1, 4. Where's the center? If I run from -2 to 4, where's the center? 4 minus 2 divided by 2, the midpoint, right? 2 over 2, that's at 1. The center is at -1, 1. So it is x plus 1 squared plus y minus 1 squared equal 1. And didn't you move 3 units above, 3 units below? 3 squared is a 9. And the foci are at -1, 1, 2, 3, and -1, -1. So the distance from the center to the foci is 2 units. And call this a squared. Doesn't that mean that the 9 is bigger than a squared because the foci is on the y? Square both sides. Swap those. There's my answer. How about this problem? Foci are at 1, negative 4, and 5, negative 4. The center is right halfway through between 1 and 5. Well, how do you find those? Well, what's the distance between those? 5 minus 1, that's 4. Oh, time out. Yeah, halfway between 1 and 4. So take 4 divided by 2, that's 2 units. From 1, it's right there. So the center is at 2, negative 4. So it is x minus 2 squared plus y plus 4 squared equals a 1. And how does this work? I moved the foci is the square root of a squared. Let's call this a squared and b squared. We know the stretches along the x, so the a has to be bigger than b squared. And that is how many units? If I am at 2. Oh, wait a minute. That doesn't make sense. 2 units from 1, that's 3. Oh boy. There we go. So if I am at 3, it's 2 units to the left, 2 units to the right. Square both sides. A squared minus b squared equal a 4. That's very good. And the graph passes through the point 3, 1, which means if I replace x by 3 and y by 1, that equality should hold, because that resembles all the points on this ellipse. So, if I replace x by 3, that's a 0. Y by 1, that's 5. 5 squared is 25 over b squared equal 1. So b squared equal 25. Put a 25 there. A squared minus 25 equal 4. So a squared is 29. And that's my equation. It is really x minus 3 squared over 29 plus y plus 4 squared over 25 equal a 1. And last two problems. We have a hyperbola. Foci are at negative 2, 2. And at 3, 2. So I'm running from negative 2 to 3. That's a distance of 5 units. Negative 2, oh, 4, 2. I'm sorry, not 3, 2. I misread. 4, 2. 1, 2, 3, 4, 1, 2. So I'm running from negative 2 to 4. That's 6 units. Half of that is 3. There's the center. The center is at 1, 2. Right? From 1, 3 units to the right, 3 units to the left. So it is x minus 1 squared, y minus 2 squared equals a 1. And since the foci are along the x-axis, the negative is in front of the y. And let's see how this works. Foci is the square root of a squared plus b squared. There is a squared, there is b squared. That equals how many units? From the center, from 1 to 4, that's 3 units. So we have a squared plus b squared equal a 9. And it passes through the point 3, 2. Put 3 right there and 2 right there. That should hold. A 3 in there. 3 minus 1 is 2. 2 squared is 4 over a squared minus. Put 2 in there, that's a 0 equal 1. If you cross multiply, that means a squared equal 4. And if you put a 4 right there, 4 plus b squared equal a 9, so b squared is a 5. And there's my answer. And if I look at the last question, we have vertices. Again, the graph is not part of this. We have vertices at -1, -1. and 3, -1. These are vertices. Well, between -1 and 3, that's 4 units. Half of that is 2. So 1, 2. There's the center. The center is at 1, -1. So it is x minus 1 squared, y plus 1 squared equal a 1. The negative is in front of the y because the graph is opening along the x-axis. And do you notice from the center I moved 2 units to the right, 2 units to the left? The equation of the asymptote, one of the asymptotes. So, how do you find the slope of the line? You say rise over 1 equals 1/2, cross multiply. So a is 2. And if you square that, you get a 4 as well. Oh, that's not working. Something's not. Oh, I got it. My mistake. I got excited there. Forgive me. There. You rise a units. And you run, what do you square to get 4? 2. And that is 1/2. And if you cross multiply, you get 2a equal 2, so a is 1. And there's the equation. And that's pretty much it for this section.